This is Geometry, Unit 5, Quiz Number 2 Review. For any rhombus ABCD, decide whether the statement is always, sometimes, or never true. Draw a sketch and explain your reasoning. So if we have ABCD, we have a rhombus, so that means all the sides are the same. It's a type of parallelogram. So this is an okay sketch that might indicate that all sides are the same. A, B, C, and D. Well, two letters means a segment. So those two segments would not, AB is greater than BC. That wouldn't happen because they're supposed to be the same. Well, let's come on over here. We have the measurement of angle A being greater than the measurement of angle B. Well, the way I drew my picture, it was yes. But there's no reason that the obtuse angle has to be A, so that would be sometimes. Classify the special quadrilateral. Well, here we know we have two sets of parallel sides, so we're guaranteed to have a parallelogram. And we see that the sides are not, consecutive sides are not the same, so it's not a rhombus type, but we do have right angles, so this is a rectangle. We have right angles. And with these right angles, we could verify that we would end up having 4 right angles. Because if you have parallel lines, then the consecutive interior angles are supplementary. Well, here, if we have all the angles the same and all the sides the same, we'd have a square. 4 congruent angles and 4 congruent sides. Here we have diagonals that bisect each other and they're perpendicular to each other. So if they both bisect, then this has to be a rhombus. And the reason why is that diagonals bisect each other. And let's say they bisect each other and are perpendicular. Bisecting each other would mean that it's just a parallelogram, but it's the perpendicular part that brought that all the way to become a rhombus. We're going to sketch a quadrilateral. So it's going to be an isosceles trapezoid, ABCD, and list everything we know about it. Isosceles trapezoid. Well, an isosceles trapezoid has one set of parallel sides and has legs that are the same length. If we're going to talk about everything that we know about it, one set of parallel, let's call it sides, one set of congruent legs. The bases would be the parallel part and the legs would be the non-parallel part. We also know that the base angles are congruent. Two sets of congruent base angles. Diagonals are congruent. They need to be the same length also. So that's the real important stuff that we know about an isosceles trapezoid. Of course, there's 360 degrees, there's 4 sides, we have supplementary angles between the parallel, but what's special about an isosceles trapezoid would really be the 2 sets of congruent base angles and the diagonals that are congruent. The legs that are the same length. That's pretty unique just to an isosceles trapezoid. Talking about a square. Well, there's a lot of different parts that are true about a square. We have 4 congruent sides. And angles. Kind of abbreviate all that. We have diagonals. Are perpendicular, congruent, and bisect opposite angles. We know that has all parallelogram properties, which would be opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. But some of the big parts that are really unique to just a square is it has the 4 sides and angles that are congruent. There's only one shape that does that. Diagonals are perpendicular. That's because it has the equal sides. They're the same length. That's because of the equal angles. And they bisect the opposite angles. That happens with shapes that have the same length sides. So we look here, and we know that this shape is a rhombus. So if it's a rhombus, then 44 is all the sides. If it's a rhombus, then we know we have 90-degree angles. If this is 71, that makes that 71. If that's 90 and this is 71, that makes that 19 and that 19. We don't have any diagonal information, so we don't have to. Oh, RU, sorry. RU is 20. So we know that UT is 20. The whole thing, SV, is 26. So we get 13 and 13. So let's see what information we can fill in now. The measurement of angle URV let's see. Of course, a rhombus is going to bisect the opposite angles, so that has to be 71, and that's 71, and that's 19, and that's 19 also. There's 71 degrees. Angle RVT would be 19 times 2, which is 38 degrees. RT would be 2 times 20, which is 40 units. and SU is half of the 26, which is 13 units. For the given sentence below, decide whether the statement is true or false. Write a converse and decide whether the converse is true or false. If a quadrilateral is a rectangle, then it is a parallelogram. Every rectangle is a parallelogram. If a quad is a parallelogram, then it is a rectangle. What do we think about that? That's going to be false. I can make a quadrilateral that is a parallelogram not be a rectangle. A counterexample would be a rhombus. That would be a parallelogram that isn't a rectangle. Doesn't have to be. A quadrilateral is a parallelogram, then it is a rhombus. That would be false. The counterexample would be a rectangle. If a quad is a rhombus, then it is a parallelogram. That would be true. Every rhombus is a type of parallelogram. Okay, last one here. If a quadrilateral is a square, then it is a rhombus. Well, think about it. Let's change it up a little bit and say, if a quadrilateral has 4 congruent sides and 4 congruent angles, then it has 4 congruent sides. Well, true. The converse, if a quad is a rhombus, then it is a square. So what that says is if a quad has 4 congruent sides, then it has 4 congruent sides and 4 congruent angles. That would be false. So in the diagram, ABCD is an isosceles trapezoid. PQ is the midsegment. Well, that's 75. We know that this guy is going to be 75. This guy's going to be 105 because they're supplementary. And this guy is 105. 75. 105. And we know that PQ is the average of those. So PQ equals half of AB plus DC. So that makes that 30. So now we know that this is 30 units. Angle B is 105 degrees, and angle 5 is 105 degrees. Both quadrilaterals are kites. Find all the missing angles. Well, what we know about a kite is that the short diagonal, those go to congruent angles. So those two angles are congruent. We'll call them both the same amount. So we have 2x plus 124 to equal 180. When we subtract 124 from the other side, we're going to get 56. So x is going to be 23. Both angles are 23. Okay, on this side, what do we got? How are we going to work this one? Well, the short diagonal is going to be 88. So now I have 88 and 88 is 176. So that's 283. So let's call this guy x. So we have 107 plus 2 times 88 plus x equals 360, because we know the interior angles of any quadrilateral is always 360. And 80 is 160, and then 16 more, 176. So 283. So it looks like our missing angle down here would have to be 77. For number 13, we're going to find the value of x. Well, these are diagonals. Don't get confused thinking these are angle measures. These are diagonal lengths, and we know here one thing we'd have to be familiar with is for this trapezoid to work out, we'd need legs that were the same length. That would be important to know. So now we can look at this and say that 3x plus 6x minus 5 is going to equal 5x plus 2 plus 21. (9x minus 5), 5x plus 23. We're going to minus the 5 this way, add the 5x that way, or this the 5. So some other options on ways you could have set it up. They don't bisect each other, so this portion is not the same as that portion, but the two top portions would have been the same. The two bottom portions would have been the same. I just took the full diagonal. If an isosceles trapezoid then diagonals are congruent. That's the property that I used, the theorem. Okay, what do we think about this one? What could we do? First of all, what type of shape is it? Here we see it's a parallelogram. It's what's on one set of parallel sides. This appears to be a midpoint because you have two sets of congruent sides on either side. Same thing here. So this is a mid segment. So I know that the mid segment, see where I can write this, is going to equal half x plus 3x times by 2 to get 36, divide by 4, Number 14. In a kite, the measure of the angles is 6x, 24, 84, and 126. Find the value of x. Well, what do we need to know? We know that 6x plus 24 plus 84 plus 126, it has to add up to 360. So 6x, so that's 200, 210, 234. When we subtract the 234 across, we're going to get 126. So x would have to be 21 degrees apparently. Here's our shape, and we're going to work it out using many different scenarios. If B is 73, what would C be? Well, they would have to be supplementary. Angle A is 51. What would angle D equal? Well, they're going to be supplementary again. If angle C was 112, what would CFE? Right there and right there are going to be supplementary to each other again. If AB is 28 and DC is 13, then what is the mid segment? Well, the mid segment is going to equal half of 28 plus 13. Half of 41, which is 20.5. If EF was 13 and DC was 6, then what's AB? The mid segment is 13. AB plus TC. So we're going to multiply by 2 to get 26. subtract it to get AB equals 20. Quadrilateral ABCD has congruent diagonals. What type of quadrilateral meets this condition? Congruent diagonals. You would have congruent diagonals, so a rectangle, a square, that's a type of rectangle, and then the tricky one is an isosceles trapezoid. Quadrilateral ABCD has exactly one pair of opposite angles that are congruent. What type of quadrilaterals meet this condition? Exactly one pair. So that would be our kite, and it would have one pair of opposite angles that were congruent. No other shape's going to have that. A rhombus is going to have two, but I'm under, yeah, exactly, meaning it could only be one pair. So kite. Determine whether the statement is sometimes, always, or never true. Diagonals of a trapezoid are congruent. That is sometimes true. When would it be true? If it's an isosceles trapezoid. All angles of a parallelogram are congruent. And that's going to happen in a rectangle and a square. Let's just jump down here. Opposite angles of an isosceles trapezoid are congruent. Opposite. Oh, I'm sorry. I never said sometimes or never. Angles of a parallelogram are congruent. That doesn't happen all the time. Not for all of them to be congruent. Opposite angles of an isosceles trapezoid are congruent. That's going to never happen. Because if that happened, then you'd turn into a parallelogram. Diagonals of a parallelogram are perpendicular. So diagonals being perpendicular sometimes happens. A square is a rectangle. Always. A square has 4 right angles. A square is not a rhombus. Always. Rhombus has exactly one pair. A square is not a rhombus. Oh, I'm sorry. Now I'm getting confused myself. A square is a rectangle. Always, a square is for. A square is a rhombus. That's always. A rhombus has. I was thinking of something different there. A rhombus has 4 congruent sides. Looks like I skipped this one up here. Opposite sides of a rectangle are congruent. Always. 2 sets of, not parallel, but congruent sides. And our last question. If XO is 3 and OZ is 3, YO is 7, and WO is 10, find the lengths of the sides of the kite. Oh, look at this one. This is actually the Pythagorean Theorem. A squared plus B squared equals C squared. We'll be safe on this one from our quiz. So we can look at this and know that it's called A squared plus B squared equals C squared, or some call it leg squared plus leg squared equals hypotenuse squared. So we don't know what the hypotenuse is. So 9 plus 49 is going to be 58. So if this is 58, so is this side. Now we look to this portion, and it's going to be a teeny bit different. We're going to get 3 squared plus 10 squared equals WX. That's our hypotenuse here, because remember, diagonals are perpendicular in a kite. So 9 plus 100 equals WX. 109 equals WX. You should be safe from this question. We'll be going over this in detail in the future when we do right triangles, but this is not part of our notes, so you should be safe with number 25. Good luck, everybody.